We have to have a way to differentiate these with names. Okay. Take a look at these, see if you can find the pattern this time. Yeah. You can just put a prefix on saying how many of them there are. Okay. If you have a 1 for the first element, you don't say mono. It's not monocarbon monoxide. If you have a 1 on any other element other than the first one, here there are only two different ones in each one, but you can have 3 or 4. Any other element other than the first one, you do put the mono. Okay? There's carbon dioxide, carbon tetra. Tetra is 4. Sulfur trioxide, tri is 3. Dinitrogen tetroxide, and then phosphorus pentafluoride. So you have mono, di, tri, tetra, penta. Okay. In homework, you may run across hexa, and then hepta, and then octa. My guess is they would not go to nana, and then deca, and then undeca, or something like that. So here are 1 through 10. Okay. I would say in here, I mean, once you get into penta, hexa, hepta, it's pentagon, hexagon, heptagon, right? Octagon. Those you know, right? It's the same prefix that you already know. The tri and the tetra may get you. Okay. It's di, not bi. Okay. It is di.
Triangle.
Triangle, but there's no diangle. There's I guess a monangle would be a line. What's that called? Sulfur dioxide. So it's sulfur, 1 sulfur. It's the first element, so you don't say mono. It's just sulfur dioxide. That one?
Nitrogen,
Trifluorate.
Trifluoride. Tetra phosphorus.
Tetraphosphorus.
It's deca oxide. Deca oxide is kind of clumsy to say, so in that case, in deca oxide would be perfectly fine by me with a quiz or anything. It's deca oxide. Okay. But if say you had fluorine, it would be decafluoride. That's it. Name the first element, just like a metal. Just say the element. If you have to add a prefix, add it. For the other one, name it like you would an anion. Put the "ide" on it. Put the prefix on it if you have to. Right? Done. Okay? Was that easier than ionic? Yes. Here's some more. Name of that one? Sulfur trioxide. What's 6? Hex. So sulfur hexafluoride. Dinitrogen tetraoxide, or tetroxide. To me, tetraoxide is easier to say than tetroxide.
Yeah.
Carbon monoxide. What's 5?
Penta.
Penta. Phosphorus pentachloride. There are some that have common names. These are the only 3 you have to memorize. One of them, if you got wrong, okay, water, right? Water is a common name. When you think about it, it is. It's a common name for a chemical. Ammonia, you certainly know ammonia, but ammonia is NH3. And I guarantee you, several people throughout the rest of the semester are going to get ammonia and ammonium mixed up. Okay? Ammonia is NH3. That is a compound. NH4 plus is an ion. Okay? And then hydrogen peroxide, H2O2. Acids and bases have their own naming system. Okay. Acid is something that when you put it in water, you get hydrogen ions. Okay, so here we have HCl, it's hydrochloric acid, we'll learn how to name them. It's hydrochloric acid going into water gives you H plus, the hydrogen ion, and the chloride ion. Okay, just like NaCl, works the same way. But because it's giving us an H plus, that means it's an acid. Acids give us H pluses. H pluses don't really exist in water. Okay, it's great to think of them, and we're going to have a whole lecture on acids and bases later in the semester. So don't worry about this too much at this point. But if you see an H3O plus, what that is, if you have water and you add an H plus to that, what do you think you would get? If you had H2O and you added H plus to it, just combine them together. Here, how many hydrogens do you have here? If you add one, how many do you have? H3, you have an O, you don't add any, so you have H3O. Here you have a neutral charge, and you added a plus charge, so now you have H3O plus. Okay? That's what this H3O plus is. Because hydrogen, H plus doesn't like to float around on its own, it latches onto a water. And so we get H3O plus.
That makes acid.
Yeah. So an acid actually has H3O pluses in it. Okay. Bases react with acids to form water. Okay. Any acid and base reaction is going to make water. Okay. So if you had say we're working with H plus, not H3O plus. If you had H plus and you wanted to make water, H2O, what would you have to add to that?
H minus.
OH minus. Now we have two H's, one O, that's our H2O, a plus and a minus cancel out. Just H2O, no charge. Okay. So bases, in general, especially at this point, bases give us OH minuses in water. Acids give us H pluses, bases give us OH minuses. So when you combine them, the OH combines with the H plus to give us water. Okay. Just like our sodium chloride, HCl breaks apart into a chloride ion and our H plus, but then that H plus grabs onto a water. So here you have a red oxygen and 3 white hydrogens stuck on it. That's our H3O plus. Here is our base. This is, again, past this lecture, but ammonia is something we call a weak base. It doesn't start with an OH in it. It has to make it. Okay? When we put NH3 into water, we get ammonium ion and OH minus. Okay? So in this base, we have OH minus floating around. In the acid, we have H3O plus or H plus. just like with our oxo anions, we have oxo acids. Oxo acids are acids that have oxygen in it, okay? The most common ones are nitric acid, sulfuric acid, carbonic acid, and then one that's not up here is phosphoric acid, okay? Just like the polyatomic ions, the ones you have to memorize are listed on that document, okay? I'm thinking it is nitric, nitrous, sulfuric, and sulfurous, which we'll see here. Yeah. Maybe on the next slide. Yeah. So, let's just look, before we move on, let's just look at the first four here. What pattern do you see in the in those names? We're just looking at these four. Right. So you were taking our non-metal, our anion, adding hydro on the beginning and ic on the end, and then just saying acid. Okay? Remember, you know the name hydrochloric acid. Use that as a model. Okay? So if I have hydrochloric acid, say I have HBr instead of HCl. What's the name of HBr? Hydrobromic acid, hydrofluoric acid, hydroiodic acid. Okay. So if you just have a simple monatomic anion, add the hydro, add the ic, add the acid, and then put in the little part of the element in the middle there. When we get past that, with the polyatomic ions, it gets a little more complicated. Let's start with these two. What was the name of the ion for SO4? Just SO4 2 minus. What was the name of that polyatomic ion? Sulfate. What was the name of SO3 2 minus? Sulfite. Okay. When you make them acids, 8s become X, ites become us is. Okay? So H2SO4, it's hydrogen sulfate, it's sulfuric acid. H2SO3 is hydrogen sulfite, that becomes sulfurous acid. Okay? So there is hydrogen nitrate is nitric acid. Okay? And it's not up here, so what would you call HNO2? Nitrous acid. The anion was an ite, so it becomes us. Same thing here. Your chloric, CO3 is chlorate, chlorite is chlorus, and this one, you can actually take one more off. Don't worry about the whole hypo thing, but if you go from ic to us to hypo us, if you see that somewhere, okay? But I'm not going to test you on that. And we just did that. So here's the flow chart name acids. Does it have a polyatomic ion? No. Add hydro, say the name of the element, add the ic, add the acid. For polyatomics, if it's an 8, replace it with ic, ice becomes uses. And then we'll put the acid at the end. Okay. The most common ones we're going to see sulfuric acid a lot. I think we're going to see sulfurous acid quite a bit. We will talk about carbonic acid at the very end, because carbonic acid is actually keeping us all alive right now. Okay. What's the name of that? As an acid. What's the name of this? Hydrobromic acid. This here, that's not one of the polyatomic ions you have to know. So it is the selenate ion. So if you have that in an acid form, what would you call that? Hydroselenic acid. However you want to pronounce it, right? So you have the H became ick. Just like it was H2SO4, the sulfuric, this is selenate, SeO4, that's hydroselenic acid. What's the name of that one? What is PO3?
Phosphorus.
Phosphoride.
PO3 was phosphite. So it's hydrophos. Oh, I'm sorry, not hydro. Phosphorus acid. I apologize. I messed that one up also. It's not hydroselenic acid. It's just selenic acid. If you wrote down hydroselenic acid, cross out the hydro. Okay. In my head, I always use sulfuric acid as my model. It's not hydrosulfuric acid. Okay. It's sulfuric acid. If I said hydrosulfuric acid, that's actually a thing. What would the formula for that be?
H2O.
Well, use that as a model. What is the name of that? Hydrobromic acid. So if you had sulfur ick, with an H on it, hydrosulfur ick, that would be H and sulfur with no oxygens. So because S has a minus 2 charge, it would be H2S. That's why you can't mess up like I did and say hydrosulfuric acid, because that is its own thing. Okay, it's sulfuric acid. Yeah.
So when you move into a polyatomic cation or anion on the right side?
Anion.
So when you move into a polyatomic anion, then you drop a hydro?
Right. Right. The hydro is only there if you're dealing with a single element for your anion. Name of that one? Hydrochloric. That one? NO3 is nitrate. So what is this acid called? Nitric acid. NO2 is, if NO3 is nitrate, what is NO2? The ion is nitrite, so it becomes nitrous acid. And then what is that one? That's sulfuric acid. Okay, I think this is the last slide.
Yeah.
We talked about calculating atomic mass, right? What is the atomic mass of a carbon-12 atom? 12 AMU, okay? Here we're going to calculate molecular weight. So if I say, what is the molecular weight of carbon monoxide, we have to have a way of calculating that. That is not a definition by saying carbon-12 is 12. Okay. So atomic mass is given up here. Okay. So if the average carbon is 12.011 and the average oxygen is 15.9994, what do you think is the molecular weight of carbon monoxide? It's those two added together. Okay? That's all it is. Add the mass of each atom together to get the molecular weight. For H2, remember H2 is one of those diatomics, there's 2 hydrogens. So each hydrogen is 1.01, and there are 2 of them, so 1.01 times 2 equals 2.02 AMU. 2.02 AMU is the molecular weight or molecular mass of H2. NaCl, there's 1 sodium. Sodium is 22.99 up there. Chlorine is 35.45 up there. There's one on each, so you add them together to get 58.44. And let's just do one slightly more complicated one. Let's do calcium phosphate. So walk me through this. So, yeah. Calcium is what? 40.078, and there are how many of them? There are 3. Times 3, what's my next element? Phosphorus, what's the weight of phosphorus? 30.9, let's say 30.97. 30.97, how many of them are there? 2. There's 1 here, but there are 2 phosphates. There's 1 phosphorus for every phosphate. There are 2 phosphates, which means there are 2 phosphoruses. Okay? You have 2 phosphorus, then you have oxygen. Oxygen is, well, actually, we'll say 16.00. We'll run with that. And there are how many? 8. 4 times 2, 8. So this is, we'll say that is, we'll just say it's 120. Then you have 31 times 2 is 62, 16 times 8, or 16 times 8.
128.
I was trying to avoid doing it in my head, so I turned to people with calculators and you all tried to do it in your head.
128.
Is it 128? So we got, so then we add them all up, we get 10, 9, 11, 310. Is that called 310? No?
Yeah.
Okay.
Make sure you're on the toes.
I can do calculus, but can I add? Okay. So
It's always the simple math that gets you.
yeah. So that's as hard as it is, okay? You can have a giant formula with 7 different elements and subscripts of 58 and 102 and stuff like that. But all you have to do is multiply the mass of that element times however many there are to get numbers and then add them up. Okay? Any questions? Okay.
When we have the final, is there gonna be like a practice final?
You'll yes and no. I'll just tell you right. So what my plan is, last semester, what I found the biggest problem was people got overwhelmed when they got to the final. It's cumulative. Okay? And so I'm going to try something new. As far as I know, no one here has ever done this before. It's not that the stuff is hard, it's that you forget it. Okay? So, we have 15 weeks of class. The homework for the 5th, 10th, and 15th weeks are going to be the quizzes from all of the prior weeks, plus the new stuff. Okay? So in those weeks there will be no book work. It's just going to be all of the previous quizzes. But I'm also going to tweak them so you can't just look at your quizzes and write them. So I'll change the numbers, I'll change the elements, stuff like that. That way you try to keep that in your head, okay? So that you don't forget about sulfurous acid 2 months from now, right? Because you're going to take the quiz on it next week, okay? And so what's the content that's in those quizzes, in my opinion, is about as good as a prep as you're going to get for the final. Okay? So you want to use those quizzes in those the cumulative homework quizzes things as your practice. Okay? If you can do those, you'll do well in the final. Okay? So we finished a little early. Before we go on to the